All right, lesson 36, critical numbers. What is a critical number? Well, first of all, I tend to forget to remind you of this often, so don't forget. To be a critical number of a function, the critical number must be in the domain of the function. So just if you had 1 over the square root of x plus 7, negative 7 would not be a critical number. Anything less than negative 7 would not be a critical number because that function would not exist. So first of all, make sure that when you're checking for critical numbers, the critical number is in the domain of the function. All right, what is a critical number? Well, a critical number is anything within the domain of the function that allows the first derivative to be 0 or the second derivative or the first derivative to not exist. Either the first derivative equals 0 or the first derivative does not exist. Then that value of x we'll call c, indicating it's a critical number. Well, when the slope equals 0, right? Let's see what I've got. If the slope is 0, oh here, I've done it down here. If the slope is 0, it looks like this. If the slope does not exist, there's two possibilities. There's a possibility that it's formed these things that we call corners, like the absolute value of x forms a corner. The slope here at this would be x equals 0. 0 would be a critical number because the slope at 0 does not exist. How can I say the slope does not exist? Well, I look at it this way. I look at the function, the limit of the derivative, not of the function, the limit of the derivative as x approaches 0 from the left-hand side, that's negative 1. And then I turn around and the limit of the derivative as x approaches 0 from the right-hand side, that equals positive 1. Well, if the slope from the left doesn't equal the slope from the right, then the slope does not exist. That's what gives us a corner. Another possibility for the slope does not exist is when, this is hard to see, is when, for example, the function is x to the 1/3, the cubed root of x. The derivative of that would be 1/3 x to the negative 2/3, which would be 1 over 3 the square root of x squared. Well, when x equals 0, the function does not exist. So in this case, right here, it comes up here, makes a vertical asymptote, and goes on. All right. So those are the two possibilities. This one's not quite as often. This is what we're normally working with, but we can't forget. Whoops, we can't forget about that one. But this is the one we're normally working with when the slope is 0. See what happens when the slope is 0? The function comes up, it reaches the slope of 0, and then it goes back down. Or it comes down, reaches the slope of 0, and goes back up. It's also possible, like over here, it comes up here, reaches the slope of 0, and then keeps on going. All right, that's also possible. So we have to keep that in mind. All right, so what do we do with these critical numbers? All right, what we do with the critical numbers is we use them to help us find local or absolute, local mins and local maximums. Local minimums and local maximums. That's different than absolute minimums and maximums. We'll work on those in a few weeks. But right now we're talking about local mins and local max. What do I mean by local? I mean the point where the function turns around. Our turning points is what we've been calling them. Remember, x to the 4th has at most 3 turning points. It either has 3 turning points or 1 turning point. So it's either going to look something like this, or x to the 4th could also look like that 1 turning point. How do we find the x value? How do we find the x value, right, this guy right here, the x value of where those turn around? We find when the slope is 0. All right, so when the slope is 0, the function will turn around. That will give you a turning point. This value right here would be a critical number. This value would be a critical number. This value of x would be a critical number. This value of x would be a critical number. This particular function would have 4 critical numbers. All right, so that's what we use it for. It's not an absolute minimum max. See right here, this would be an absolute maximum. But even though this is a minimum and this minimum is below this minimum value, this local minimum value, it's not the absolute minimum of the function, because see, the function goes on forever. So this function has, if the domain is all reals, this function has no absolute minimum, but it does have 2 local minimums and 3 local maximums and 1 absolute maximum. Alright, let's do some problems. This is actually easier than it sounds. Let's do problem 36 one. Alright, so the function is x cubed plus 9/2 x squared plus 6x plus 5. Okay, x cubed has at most, has at most two turning points. It's a positive x cubed, so I know it's going to look something like that, right? I'm going to take the first derivative and figure out the x value of this point and the x value of this point. I want to find those 2 critical numbers. Alright, so the first derivative is 3x squared plus 9x plus 6. First thing I'm going to do is factor out that 3. X squared plus 6x plus, factor out 3. X squared plus 3x. Back to my pen. X squared plus 3x plus 2, which simply factors 3 times x plus 2, x plus 1. So here's my function. 3 things multiplied together. What makes this function 0? Right, because a critical number I'm looking for, when is the first derivative 0? All right, the slope is 0. When do I have a horizontal tangent? That occurs at x equals -2 and x equals -1. Now I'm going to take this a little bit further than your book does right now. Alright, I'm going to say at -2 I have a 0, and at -1 I have a 0. Now remember, this is f prime. This is not whether the function is above or below the x-axis. This is the slope. The derivative is the slope. Is the slope positive or negative? Well, for values less than -2, this is negative and this is negative, so it's positive. For values between -2 and -1, this now becomes positive. Well, that's negative, so this becomes negative. And values greater than -1, this whole thing switches over to a positive. So what does this slope, positive slope, means? It means that the function is increasing, then the function has a slope of 0. Between -2 and -1, this function is decreasing, it has a negative slope, and then from -1 on, it has a positive slope. So increasing to decreasing, that means at -2, at the critical number -2, I have a local maximum. At the critical number -1, my slope changes from decreasing to increasing. Therefore, at x equals -1, I have a minimum. So those are my 2 critical numbers, x equals -2 and x equals -1. And I can take it further. I can take it further and say that -2 is a local maximum. When x equals -1, the function reaches a local minimum. The value of the function at -1, I'd have to put back into my original function to find it. All it is asking me is, where do those minimums and maximums occur? All right, let's look at example 36-2. All right, for this one, I'm looking for the critical numbers. What are the critical numbers? Well, to find critical numbers, f prime of a critical number, I don't like that color, go to this color. F prime of a critical number equals 0, or f prime of a critical number does not exist. All right, to be a critical number, it has to be in the domain of the function. This is a simple polynomial, so the domain is all real, so I don't have to worry about that. Again, it's a simple polynomial, so let's take the derivative. F prime then, 4 times 1/4 is magically x cubed. Minus 1/3, minus, bring that 3 down, so minus x squared, minus 2x plus 0. All right, since I'm looking, this derivative, when does it not exist? It's a simple polynomial, so it always exists. It's an x cubed. It's a positive x cubed. So again, we know it's going to look something like this, right? So again, yeah, 1, 2. Oh, wait, sorry, that's the derivative. The function, let me switch over here. The function is an x to the fourth. I knew something was wrong there. I was going to get 3 critical numbers. The function x to the fourth, a positive x to the fourth, has 3 turns or maybe only 2 turns. So I know that I'm looking for 3 critical numbers. I'm looking for 3 turning points. So what is the x value of those turning points? Not the y value, not how high or low it goes, but left and right. Where are the x values? So I'm going to factor this, go back to the derivative. I'm going to factor this, pull out an x, and I'm left with x squared minus x minus 2. So the first derivative is now x times x minus 2, x plus 1. So when does the first derivative equal 0? At x equals 0. So my first critical number is x equals 0, x equals 2, and x equals -1. Again, I'm going to take it beyond your textbook. See, I have the derivative. Remember, this is not the function, this is the derivative. The derivative is 0 at 0. The derivative is 0 at 2, and the derivative is 0 at -1. All right, when I'm less than -1, this would be negative, 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 negative. So the function would be a decreasing function. The slope, first derivative, the slope would be negative. Between -1 and 0, between -1 and 0, this changes, so I end up with a negative times a negative, or positive. Between 0 and 2, this one changes, the x becomes positive, this is positive, that stays negative, and then for values greater than 2, this switches over to positive. So I know my function, when I'm less than -1, my function is decreasing. When between -1 and 0, my function is increasing, then it turns around and is decreasing, and it turns around is increasing. So I know -1 is a minimum, 0 is a local maximum, 2 would be a local minimum. All right, so I've got 2 local minimums, which I expected, x to the fourth, that's what I expected, and 1 local maximum. I would have to put in the value of -1, so come up here, f of -1 and f of -2. Right here, f of -1. I thought I switched that. And f of -2 to find out what the absolute minimum value is. But right now we're just talking about the local mins and local maxes. Okay. All right, let me give you a quick caution. I mentioned this in class, but let me give you a quick caution. If there is a local min or local max, if the function turns, then that is a critical number. That will occur at a critical number. If it's going to turn, that will occur at a critical number. At a critical number, if you have a local min or max, that will occur when f prime is 0 or when f prime does not exist. However, just because you have a critical number does not mean that you have a min or a max. All right, it's possible that your function comes up, slope doesn't exist, and has a slope of 0 and then continues on. It's also x cubed is a good example of that. X cubed looks like this. It has 0 turning points. X to the 1/3, we saw that one earlier, x to the 1/3, although 0 is a critical number, 1/3 x to the -2/3 is f prime. Function does not exist when x equals 0. Even though that's a critical number, it's not a min or a max. So one more time, if you have a min or a max, that will occur at a critical number. However, the whatever this is, inverse, I think, inverse is not true. Just because you have a critical number does not mean that you have a min or max. You have to apply what's called the first derivative test or the second derivative test. What I was doing earlier is the first derivative test. If this is zero, this critical number, and my slope changes from positive to negative, then that critical number provides a maximum. If this critical number 2 gives a value of 0 and the slope doesn't change, then that's not a min or a max. You have to test it. Just because it's a critical number, you do not have a min or max. But if you have a min or max, that will occur at a critical number. Okay.